All right, welcome to video 3 of week 11. This is going to be our longest video. This is going to be about the ellipse, which is the more technical word for the more technical version of the oval. We're never going to call it an oval, though. An ellipse, or ellipse for plural. So notice how circle has one center. In a ellipse, we're going to have two centers, but we're going to call them foci. So let's start looking at what we have for ellipses. So let's look at our definition, right? Our little formal definition that kind of explains it in terms of distances, and hopefully I'll try to find a video, or I'll make the video of how to draw an ellipse using a piece of string. So we can kind of understand what this means. So an ellipse is the set of all points. So start off just like the circle. The set of all points in a plane such that the sum of the distance from any point on the ellipse, and remember what we mean by that is the edge or the outline, the ellipse, and the two given points which we call the foci, is constant. Not too sure. The two given points is a foci. So here we see an ellipse. We could also have an ellipse that is wider than taller. What we call the longer axis, so right, vertical, horizontal, we're used to those words, but we're going to call the major axis is the longer one, and that can either be horizontal or vertical. The minor axis is the shorter one, which can sometimes be vertical or horizontal. So the center of the ellipse is the location where the two axes of symmetry intersect. So here, right, we can see the major axis, the minor axis, and they intersect at point C, which is the center. The other 2 points, the foci, I'm sorry, not the foci, the vertices are the location where the axes of symmetry intersect with the ellipse, and that's the edge. So those vertices would be these dots right here. We have one vertice, 2, 3, 4. Those are the vertices of the ellipse. So let's start looking at some examples. This is a little bit more complicated than a circle, but it's still within manageable reach for week 11. So let's try to use our cheat sheet. So I'm going to go to it once, and I'm just going to refer back to it because I have it open on a separate device. But all the way in the back, we have all this stuff for an ellipse. So we have the equation, which remember we said we're going to call this vertex form, even though it's not really what we should call it. Notice how we have a fraction now with a and b on the bottom. Circles, we just had r, which is radius, because that radius was the entire, was the same all the way around. A, you can think about it as like the radius in the horizontal direction. B, you can think about as the radius in the vertical direction. It's not the best way to think about it because we shouldn't use the word radius, but that's what we can use mentally. And then we have equals 1. We always want to equals 1 on one side of the equation. The center is still HK, just like it was for the circle. Vertices are those edges of it. And we can see that we just take our center and we add our horizontal radius to H and then subtract it and vice versa. Our axis length, kind of like our diameter, right, is 2 times B, which don't worry about, we'll talk about why this. If A is greater than B, we'll talk about what that does. If A is greater than B, that means our horizontal radius is bigger, which means we will have a fatter and shorter an ellipse. If B is greater than A, then we have a taller and skinnier ellipse. And then we can kind of see that. What is the most difficult part of the ellipse is finding the locations of each focus. There's two foci. All right. We need to know which type of ellipse we have because we find this C term, which is the distance from the center, and we either add or subtract it to H if we have our horizontal ellipse, or we add and subtract it from K if we have our vertical ellipse. To me, that makes sense because, right, our foci will be up here. Those are our 2 given points, so we need to add them to our center. So let's try to understand this by looking at an actual problem. That's the last time we're going to be looking at that page during the video, so hopefully you have it open somewhere else or had printed it out. So when we have it given to us in vertex form, we're happy, all right? Because then we can graph stuff pretty quickly. So what we should always do first is to find our center. So our center is HK. And then if we remember our vertex form, we have x minus h squared over a squared plus y minus k squared over b squared equals 1. We have the 1. All right, so that means h and k are inside the parentheses. We have x minus 2, compare that to x minus h, means that h is positive 2. Next, we have y minus k, we have y plus 1. So that means k is negative 1. So we can plot that right away. We have 2, negative 1. That's our center. Now we can find our a. Our a is underneath our x, always. And we have a squared is equal to 9. So we can take the square root of both sides to say a is equal to 3. A is underneath our x. X is how far left or right we go. So that means for a, we go 1, 2, 3 to the right and 1, 2, 3 to the left. So that will figure out how wide our ellipse is. Using our h and our a, we always figure out how wide it is. I won't ever ask you for like the locations of the vertices, but the vertices is how we actually draw our ellipse. Next one, we have b squared is equal to, we look underneath the y, it's 4. So that means b is 2, which means our vertical radius is 2. So we go from the center up to this vertex, down to this vertex. So we can draw in to the best of our careful ability what our ellipse will look like. Kind of fitting that we're doing this around Easter because an ellipse is kind of like a balanced symmetrical egg. So there you go. So that's our ellipse. But we still need to figure out a couple more things. So we need to find the location of those 2 foci. And to do that, it's actually a little bit of work. We have to find our C value, which is the distance from the center to our focus. It's not that bad. All right, and this is all for finding the focus. We do c squared is equal to a squared plus b squared. That's the same no matter what. So we get c squared, we take a squared, which is 9, right from the bottom, plus b squared, which is 4, right from the bottom, to get 13. So c squared is equal to 13, which we take the square root of both sides to get c is approximately equal to, and we do want those approximates here, 3.61. Notice how that's just a value. It's not a coordinate point. So our next step is going to be finding the locations of the foci. If we look at our graph, all right, we start at our center. I made a mistake. So I did not carefully look at our cheat sheet, our last 2 pages. So c squared does change based on what type of ellipse we have. We have a horizontal ellipse, which means in this case, a is greater than b. So if that's the case, we do c squared is equal to a squared minus b squared. I was thinking Pythagorean theorem, and this is not quite it. All right. We have c squared is equal to a squared minus b squared. So a squared is 9 minus b squared is 4. So we get 5. So c squared is equal to 5. Take the square root of both sides. So we get c is approximately equal to 2.24. So now we're back at the situation we were before I noticed my mistake. And we want to figure out, if we start at the center, how far away are our foci? What we saw on our cheat sheet was that we need to add or subtract c to either the first term in our center or the second term. And it always matches up with which a or b is bigger. Since a is bigger, that means we add or subtract to the h, which makes sense because if we're at our center, we want to go to the right and to the left because that's where the most space is. So let's do that. Our center is 2, -1, and we want to add or subtract that 2.24 to our h. So we're going to get 4.24 -1. So that's just about right here. And then we have the other one where we subtract, so that's -0.24 -1. So that's just a little bit left of the y-axis, so right here. So that's our completed drawing. We have the center, right? We use our vertices to draw our outline, and then we drew our foci. So we hit all the required pieces. Let's look at another example. This time we have to use our completing the squares method. So same as with circles, we want to group our x's together. We want to group our y's together. And then we want to move anything to the other side. Okay. So we were lucky with the first one. We have x minus 3, right? We take our b, divide it by 2. And then we subtract b squared over 4. And then over here, we're not so lucky. First, we have to factor out that 4 from each part. All right. Which would then be plus 4y squared minus 2. No square on the inside, sorry. And then on the outside, if we remember our formula, we would do minus a, which was 4, b squared, which is -4, all over 4. So some stuff cancels out here, so we're left with just minus 16. So we have, and then if we clean that up, we have x minus 3 squared minus 9. So we can add 9, add 16. These cancel out. We add 9, add 16. So we end up getting as our equation x minus 3 squared minus add 4y minus 2 squared is equal to 36. But this is not what our standard form is, right? We want a 1 on the right. So we divide everything by 36. Whatever is on the right, we divide by that. So I'm sorry, running out of space. I'm going to try to fix that by scooching it over to the left. So if we do that, we have x minus 3 squared over 36. But here we can simplify. So we have plus y minus 2 squared over 9 equals 1. So now we have it in vertex form, just like what we had for example A. And now I'm going to try to switch color because unfortunately I will have to kind of fit everything here. So our center is at HK, which here we have 3 for H, 2 for K. So let's graph that. 3, 2. Here's our center. All right. We have A squared is always underneath the X, so that's 6. Our B squared is underneath the Y, so that's 3. So A, remember, tells us how far left or right. So we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then we go 3 up and down. 1, 2, 3. 1, 2, 3. All right. So that's what our ellipse will look like. Try to make it look like a nice smooth ellipse. It should not look like a football. It should not look like an egg. It should look balanced and curvy. So that's our ellipse. We have our center. We have our outline. Last thing is just our foci. So we need to always check ourselves. A is bigger than B. So we do c squared is equal to, and we just take the bigger thing minus the smaller thing. So here we have 36 minus 9. So that's 27. We take the square root of both sides. We get something we're going to have to approximate. So 5.1, oop, I have to round it, 5.20. So that's our C. Again, there's just more space left and right. So we're going to take our center. We're going to add C to the right, and then we're going to subtract C to get to our left. So if our center was 3, 2, we would do 3 minus 5.20, and then we don't change the y value, so that would be negative 2.202 as one of our foci, so negative 2.2, and then we would do 3 plus 5.202, so we get 8.202. So notice how the foci are usually pretty close to the edge of the ellipse, and the more drastic the differences between the height and the width of the ellipse, the closer the foci are to the edges. So here we have our final ellipse. I think that was a lot of information to soak in, so you might have to rewatch this video. I will talk about these a little bit. So for number 2, just like in the other example, we're actually working backwards. We didn't really talk about vertices versus co-vertices. I don't think it's worth it, but we can just figure this out. All right. It's just one of these is the major axis, one of them is the minor axis. If we graph this, 6, -6, -2, 4, -2, we can just do this roughly. -6, -2, 4, -2. All right, and then if we go to -1, -4, and then -1, 0, we can see right away that we're going to have, as we've seen in these 2 examples, and in our 4th example, that's not good, a horizontal ellipse. So we know that because it's bigger in the x direction, A is going to be bigger than B. All right, so to figure out what A is, it's not actually that bad. We need to find the distance between these 2 points. But because the y's are the same, it's like we're on a number line. So we do, we take x2 minus negative 6, so we get 10, and we divide it by 2. No, we don't. We just keep it like that. So we get 10 is the entire width of the ellipse, but we want to find the radius, right? So that's the diameter. So the radius is 10 over 2, which would be 5. So that's A. So we can already say we would take x, that's in parentheses, divide it by a squared, so 25. Take y in parentheses, divided by b. So let's figure out what b is next, and that will be with these two values, right? Negative 1 stayed the same, so we're not going to use that. So we're going to do 0 minus negative 4, so we get positive 4 as our diameter, divided by 2 to get to our radius. So that means b is equal to 2. So we would square that to get here, and we know that's a 1. So we really don't have much else to do. We just have to find where our two axes intersect next. And that, we didn't use it to figure out our A and B. We're going to use that to figure out those other information. So we see negative 2 is repeated. That is the actual equation of our axes. So that's in the y spot, right? So we actually use that as our axis. So that's y, that's what our center is. Our center will be at negative 2 for the y. So we need to make that positive 2, right? We need to change the sign. And then our x's stay the same at negative 1, so that's going to be plus 1. So that's how we get the equation. That won't be a focus of this, and we are not going to do number 3. So those are some examples of how to graph an ellipse by hand, how to find the most important things, which we said was the center, to find the center, to find the vertices by using A and B, and then how to find the foci by using the C. All right, those were the most important parts. I'm sorry for the long video, but I knew this was going to be a little bit of information. I'll try to find the Khan Academy videos too, and they'll go over more examples. Good luck.